Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fadizatul Balkis binti Mustafa Fadeh. Today I'm going to present the proposal presentation for my final year project entitled Improvements of the Design Materials Used in the Treatment of Pelvic Floor Prolapse. Here is the outline for today's presentation. The first part is the introduction. Pelvic organ prolapse or pelvic floor prolapse is a condition that occurs to women when the supportive muscles and tissues, which is the pelvic floor muscle that act as hammock or sling to support the pelvic organs, is weakened and resulting the pelvic organs, such as bladder, uterus, and rectum, to drop from their original places and herniate into the wall of vagina and its opening. There are several types of pelvic prolapse, which is the uterine prolapse, cystocele, the bladder prolapse, and rectocele, the rectum prolapse, that can occur in several stages according to their severity of drooping. The prolapse usually happen to older women after their menopause, and the main causes is due to pregnancy and childbirth. Other causes are obesity, genetic, and prolonged coughing that affecting quarter of adult women in the world. As prolapse can give women several symptoms that could affect the quality of their daily life, several treatments are introduced. The treatments that do not involve any surgical approach are such as inserting the pessary, practicing pelvic floor exercise called Kegel exercise, and improving diet intake, especially for obese women. However, an invasive surgical approach such as suture and implanting transvaginal mesh is needed for the severe cases. Transvaginal mesh is a net-like material made of synthetic polymer called polypropylene (PPL) that can be implanted to support the weakened muscles. Here are several designs of transvaginal meshes from different medical devices manufacturers according to types and severity of the prolapse. The next part is the problem statement. Despite of its wide uses in the treatment of pelvic floor prolapse due to its higher rate of effectiveness after the treatment, transvaginal mesh can cause discomfort to the women after several years of implanting it. The material used for the mesh tend to harden and causing discomfort for women that resulting them to undergo another surgery to remove the mesh as they harden, and the hardened and eroded meshes cuts the organ and protruded through it. Many women are reporting this adverse incident to the Food and Drug Administration (FDA), and they reclassified the transvaginal mesh as high-risk device. Here is some news header that shows the mesh failure issues and women filing the lawsuit against the manufacturer due to the mesh failure. Over 33,000 lawsuits have been filed. Next part is the objective of this project. The first one is to optimize new dimension for transvaginal mesh implant. The second one is to characterize the method of fabrication. For the methodology part, I use balloon and masking tape to fabricate the design of the meshes to find out its elasticity. I use two types of masking tapes with different width and two sizes of balloons. 3 orientations of the tapes, which are vertical, horizontal, and both orientation with gaps to design a total of 12 designs. The last step after popping the balloon is to measure its initial and final diameter after stretching it. As a result, each design has their own elasticity and measurement. Hooke's law is used to calculate the elasticity of the materials. Here are the graphs of force versus the diameter of the inflated balloon. We can see that different size and orientation of the material give different elasticity. The last part is the Gantt chart. It shows the plan from week 1 until the last week of the semester. We begin with title selections, objectives, and problem statements from first week until third week, followed by technical writing and design thinking from week 3 until week 13. Progress presentation on week 9 and 10, and the last one is final submissions and presentation on week 14. Here is the list of references that I used for this presentation, and I think that's all from me. Thank you.